Today we're going to be talking about dividing polynomials, and there's two methods we're going to study. We're going to study long division and we're going to study synthetic division. The important thing to remember here is synthetic division can only be used when we have a linear factor. Okay? Long division is similar to what we studied when we were younger in elementary school when we did numerical division. So the format's going to be similar. It's just going to look different because you're dealing with polynomials, not specific numbers. So let's look at some examples. Now in example 1 here, we're actually going to use long division, polynomial long division, to divide 4x squared plus 23x minus 16 by x plus 5. X plus 5 is called our divisor. The number underneath here, the 4x squared, is called the dividend. And here's our quotient that goes on top. Now, the key here is our x value, this. Okay, out front, we always pay attention to x. So the first thing you have to ask is, does x go into 4x squared? If so, how many times? Well, x goes into 4x squared 4x times. So we write the 4x on top, and now that 4x gets multiplied to both these terms. So 4x times x is 4x squared. 4x times 5 is 20x. I align my numbers, okay, by powers, okay, so they match, they're like terms, and I have to subtract off both these terms. The 4x better cancel out. 4x squared minus 4x squared is 0x squared. 23x minus 20x is 3x's, and I bring down the 16. So far, this would be my remainder. Now, back to x and my divisor. X goes into 3x 3 times. So we take that 3 and multiply to each term. So 3 times x is 3x. 3 times 5 is 15. And again, we subtract off both those numbers. So 3x minus 3x is 0. Negative 16 minus 15 is negative 31. So our answer is always written as quotient plus remainder over divisor. In elementary school, you would see that big R remainder 5 or something. Well, here it's quotient plus your remainder over your divisor. So 4x plus 3 plus 31 over x plus 5. So the idea here is if I took 4x plus 3 and I multiplied it by x plus 5, I would have to add 31 to that to get this value. Okay? So, and it's minus 31. Let me make sure I have that minus there. There we go. So, how do I know when I'm done polynomial dividing? Well, when your remainder's power is less than the power of your divisor, you're done. So this is negative 31. It's a constant. So x would be x to the 0 power. This is first power. So we're done. Okay, x does not go into negative 31. So I'm done. And also, since the remainder is not 0, we know that x plus 5 is not a factor of 4x squared plus 23x minus 16. Okay? So let's look at another example. Now this one is a tough example because we're going to divide x to the 5th minus 32 by x minus 2. Much longer process. And I gave you this example because notice how there's only 2 terms. You're thinking, hey, this is going to be a short problem. However, you have to add zeros. Okay? You have to start with your largest power and work your way all the way down to the constant. Notice I don't have a x to the 4th, x to the cube, x squared, or x termed. So I put in zeros in their place. Okay? So let's see how this would work. X minus 2 is our divisor. Okay? So we have x goes into x to the 5th, x to the 4 times. So x to the 4th times x equals x to the 5th. X to the 4th times minus 2x, or minus 2, is minus 2x to the 4th. And I subtract off both those terms. So you can see now, if there was no x to the 4th, I wouldn't have anything to combine like terms. So I put these in as really just placeholders, so I don't really add the wrong terms together. So 0 minus negative 2x becomes 2x to the 4th. So again, we go back to our x and say, well, does x go into 2x to the 4th? It does. 2x cubed times. So I put plus 2x cubed, and I'm going to multiply that 2x cubed to both these terms. 2x cubed times x is 2x to the fourth. 2x cubed times negative 2 is minus 4x cubed. Make sure I get my parenthesis there. Okay? And I subtract off these two terms. So 2x to the fourth minus 2x to the fourth is gone. X cubed minus negative 4x cubed becomes 4x cubed, and I bring down the 0x squared. X goes into 4x cubed, 4x times, or 4x squared times. So then 4x squared times x is 4x cubed. 4x squared times negative 2 is minus 8x squared. Subtract off both those terms, and I'm left with 8x squared. Okay? X goes into 8x squared, 8x times, and multiply 8x to both these terms, and I get 8x squared minus 16x. Subtract those off, and I get 16x minus 32. Well, x goes into 16x 16 times, and now I multiply 16 times that binomial there, the x minus 2, and my remainder here is 0. So what this tells me a couple things. Number one, x minus 2 is a factor of this. So the answer would simply be x minus 2 times this, right? So this is the two factors being multiplied out. If you multiply these two things out, you get this polynomial. Okay, so this is our quotient right here. I don't have to write the remainder because the remainder is 0, and 0, the remainder over the divisor, 0 over x minus 2 is 0. Okay, so let's keep going. Now, this one is our last one, I think, with polynomial division, I think, hopefully. We will see. So we're checking to see if x squared plus 1 is a factor of this polynomial, 3x to the fourth minus 4x cubed plus 12x squared plus 5. Well, is the remainder 0 is really the question, because if it is, then we know this is a factor. So we have to divide and determine if the remainder is 0. And notice how in one spot I've added the 0x because I was missing a term. Look, 4, 3, 2, and then it goes to the constant. I'm missing the 1 power. Okay? So now I'm going to divide this out. So I look at x squared and I ask myself, does x squared go into 3x to the fourth? It does. 3x squared times. So I have 3x squared times x squared, which is 3x to the fourth. 3x squared plus 1 times 1 is 3x squared. And notice how I match up my like terms. Subtract off. Okay, so we're going to have 0x to the fourths. Just bring down the negative 4x cubed. And now we have 12x squared minus 3x squared, which is 9x squared. So be very careful how you align your terms. Make sure they're like terms when you subtract. So now we ask ourselves, does x squared go into negative 4x cubed? The answer is yes. It goes in there 4x times. So 4x times x squared is negative 4x cubed. Negative 4x times 1 is minus 4x. And again, we align our like terms up. There's that 0x. So we're going to subtract off these terms. And we have 9x squared left. 0 minus negative 4 becomes positive 4x. Okay, we'll make that a positive. I missed that sign there. Now, does x squared go into 9x squared? It does 9 times, and you multiply 9 to both these terms. So you get 9x squared plus 9, and we subtract off both terms. And after that, I'm going to stop right here. Okay, I put a big stop. Why? This power is the first power. This power on your divisor is the second power. The remainder's power is smaller than that. We're done. Okay, why? Because I just need to see if x squared plus 1 is a factor. It can't be because I have a remainder. So x squared plus 1 is not a factor of that polynomial. Now we're on to synthetic division. Now, synthetic division you can only use when you have a linear factor. And but I mean linear factor right here. X plus 2 is linear. X is a first power. Okay? So here's the thing. The last number you get is always going to be your remainder. So how does this work? if x plus 2 is your factor, we're going to put the negative 2 out front because this number is your 0. So my factor is x plus 2. Okay, so we have negative 2 here. Inside are all your coefficients, okay, of your dividend. So 1, negative 14, 51, 54. Now, look at the powers. 3, 2, 1, 0. I don't have to add any zeros into this problem, but if I skipped a power, you have to put a 0 in there, just like we did with long division. So, factor is here. This is your 0. So if this is x plus 2, negative 2 goes in here. Opposite sign. The leading coefficient always comes down. Always. So we bring down the 1. Then we take negative 2 times 1, which is negative 2. Okay? Add vertically, so this is negative 16. Okay? So we get here to 32. Okay? So negative 2 times negative 16 is 32. That goes here. 51 plus 32 is 83. And then we have to multiply negative 2 times 83, which is negative 163, or 166, negative 166 and minus 54. You add those together, you get negative 220. Okay? So the last term here is my remainder. So number 1, we know x plus 2 is not a factor because the remainder is negative 220. So how do I write my answer? This right here is my quotient. So watch what I do. This is my remainder. Then it always goes constant. After a constant, you have a linear term. Then a quadratic. So this would actually be x squared minus 16x plus 83 minus 220 over x plus 2. That is my answer. So this number here is your quotient, and I think remainder, then it always goes constant term, linear term, quadratic term, and you can keep going depending on how large your polynomial is. So let's look at one more example. So let's divide x cubed plus 7x squared minus 38x minus 240 by x plus 5. So if this is my factor, negative 5 is my divisor. All my coefficients go inside. 1, 7, negative 38, 240. All here. 3, 2, 1, 0. I go in order from highest to the smallest power. Don't skip a power, so I don't have to put any zeros in it. Leading coefficient comes down. Negative 5 times 1 is negative 5. 7 plus negative 5 is 2. Negative 5 times 2 is negative 10. Add these two together, you get negative 48. Negative 5 times negative 48 is 240. Add those together, you get 0. My remainder 0. X plus 5 would be a factor of this. Now, remainder, constant, linear term, quadratic term. So I have x squared plus 2x minus 48. So there's my answer right here. No remainder, so I can leave that alone. So this would be my answer. Look, x plus 5 times x squared plus 2x minus 48 gives me this cubic term. But I can also fact that a little lower, and that's what I did here. Okay? So that's dividing polynomials synthetically and using long division. Any questions or comments, post them below, or you can email me at nicholas.bennett@dc.gov. Thanks.